Hi guys, so today we're going to look at two more parent functions. We're going to look at the square root parent function and the cube root parent function. Then we're just going to do the same transformations that we've been doing all year. So to start, we'll look at the square root parent function, which is f of x equals the square root of x. So to figure out what that graph looks like, let's plug in some points. So if I plug in 0 for x, square root of 0 is 0. If I plug in 1, the square root of 1 is 1. If I plug in 4, the square root of 4 is 2. So again, now that we're looking at the square root function, we need to be a little bit more creative about which values we plug in. I don't want to just pick any values. I'm going to pick ones I actually know the square root of. So another good value to pick would be 9, because the square root of 9 is 3. Values I could not pick would be any negative numbers, because I don't know the square root of a negative number. So we'll go ahead and plot those points, and you guys can see the shape of the square root parent function. All right, and there's my square root graph. All right, let's look at the cube root parent function. So very similar looking, but it has that little 3 there because it's the cube root. So again, to plug in some points, if I plug in 0, the cube root of 0 is 0. If I plug in 1, the cube root of 1 is 1. And again, I need to pick a value for x that I know the cube root of. Well, I know the cube root of 8, that's 2. And what's different about the cube root function is I can plug in negative values, because I can do the cube root of a negative. So I can plug in negative 1 and get negative 1. I can plug in negative 8 and get negative 2. And then that is going to help me see the shape of the cube root function. And what you guys will notice, it looks pretty similar to the cubic parent function. Okay? Our cubic parent function looks something like this. Same kind of shape, but that graph is a reflection over the line y equals x, because that is the inverse of the cubic function. And we're going to look at that a little bit more next week when we get into inverses. All right, so now we're just going to go through and do all of our usual vocab for both of these functions. So for the square root function, domain and range we need to think a little bit more about. All right, so the domain is the farthest left x value to the farthest right. It does actually touch 0, so that needs to have a bracket. Range is bottom to top, so the lowest y value is 0, and then it keeps going to infinity. Your graph is increasing on that interval, and then your graph is not decreasing anywhere. That graph is positive from 0 to infinity, and it's not negative anywhere. The only extrema is a global or absolute minimum, and if this graph were reflected, it would be a maximum. Does not have any symmetry. And our end behavior here is a little bit different. So as x approaches infinity, then we do know that y is approaching infinity. Now slowly, but it is approaching that way. Now, the only thing though is x doesn't actually approach negative infinity. So we're not going to put that on our graph. Now if I want to, I can say that as x approaches 0 from the right side, I could say that y approaches 0. But we're not really going to get into that much in this class. You're probably going to see more of those one-sided behaviors once you get to pre-cal. All right, now let's look at the vocab for our cube root function. Domain and range for every transformation of cube root is going to be negative infinity to infinity, just like it was for the cubic parent function. The parent function is increasing everywhere. It does not change from increasing to decreasing, which again tells us there are no extrema. It's positive from 0 to infinity, and it's negative from negative infinity to 0. This graph has symmetry about the origin, which means it is an odd function. And then end behavior is normal. We can say as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity. All right, so let's go ahead and review our transformations. It's the same chart you guys have been seeing for a long time now. F of x minus h is a shift right. Plus h is left. If that b value is between 0 and 1, that is your horizontal stretch. If it's greater than 1, that is the horizontal compression. F of negative x is a reflection over the y. So everything in that little chart on that side were our horizontal transformations. Those occur inside the square root. So if it's under the root, it's horizontal. It doesn't matter if it's a square root or if it's a cube root. If it's under the root, it's going to be a horizontal change. Now also what's different about these, finally, if I have that reflection over the y-axis for a square root function, it actually is going to be its own distinct graph. Until this point, every reflection over the y was either the same as the parent or it looked the same as reflecting over the x. But the square root graph is when this finally starts to actually have an impact on the graph that we're looking at. All right, now let's look at vertical changes. So f of x plus k is a shift up, minus k is a shift down. If I have a times that, if it's in between 0 and 1, vertical compression greater than 1 is a vertical stretch. Negative on the outside like that is a reflection over the x-axis. So again, these are all vertical changes, so they all occur outside the square root or cube root. Whichever root it is, it doesn't matter. Outside of the root is where the change is happening. Again, if we have multiple transformations, we want to factor out that b value, whatever's in front of the x, because it makes it easier to see that starting point for square roots or that point of inflection for your cube roots, either way. All right, so just reviewing parent function, reviewing transformations, same thing we've been doing, we're dealing with roots instead of parentheses. All right, this graph has gone left 2 and down 4. On B, that's gone right 3, it's reflected over the x, and it's got a vertical stretch. On C, it's gone down 6. That's the only vertical change. My two horizontal changes are inside the root, so reflecting over the y, and a horizontal compression. Remember, those are backwards. All right, and then writing the equations. So we have a square root function. It's been vertically stretched by 3, so I got a 3 on the outside. Reflected over the y-axis, so a negative on the inside, and a plus 6 out on the end. Then looking at the last one, all right, it's shifted up 3. So up 3 is going to change the plus 2 to a plus 5. Left 2, that's f of x plus 2, which means I replace x with x plus 2. So that's going to become x minus 1. Now, both of those changes occur to give us our new function. Then that function is reflected over the x-axis. Reflecting over the x-axis is negative f of x. That means that I am taking this whole function and making it negative, which means that my new function is negative cube root of x minus 1 minus 5. All right, so now the last thing we're going to do is we're actually going to sketch some graphs. Again, you can use whatever method you're comfortable with for graphing. I'm going to show by either finding the starting point or point of inflection, followed by our pattern and any changes to our pattern with stretches, compressions, and reflections, just like we did for cubic functions, just like we did for quadratic. All right, so let's start by listing transformations. We've got a vertical stretch, we've gone right 1, and we've gone up 3. Since we've gone right 1 and up 3, this was a square root function. That means our original 0, 0 from the parent function has gone right 1 and up 3. So that means that 1, 3 is my starting point. From that point, we're going to follow the pattern of the parent function. This was a square root graph, and the square root parent function from the first point was right 1 up 1, right 4 up 2, and right 9 up 3. So from that point, I'm going to go right 1 up 1, right 4 up 2, and right 9 up 3. And that's what I would do if I did not have a stretch. We have a vertical stretch, which I need to consider. So since I have a vertical stretch, I need to adjust those values. All right, so now, because I'm stretching it vertically, I'm changing that second number. I'm multiplying it by 2 because that graph has been stretched. And there is my stretched function. All right, domain and range. Remember, domain is left to right. The farthest left x value is 1. It keeps going to infinity. Range is bottom to top. The lowest y value is 3. Keeps going till infinity. All right, very similar in B, but this time we're dealing with the cube root, which means my pattern and parent function will look different. So this graph has a reflection over the x, a vertical stretch, and it's gone up 3. So since it's gone up 3, that point of inflection is going to be at 0, 3. So the point of inflection is kind of that middle point on my graph. So from that middle point, we typically go right 1 up 1, right 8 up 2, left 1 down 1, and left 8 down 2. But again, it has been vertically stretched and reflected over the x. So I'm multiplying those y values by -2. So from that point, right 1 down 2, right 8 down 4. Left 1 up 2, left 8 up 4. And there's my cube root function. Domain and range are the same for every cube root function. All right, where these really get the trickiest is when we have anything in front of that x on the inside. So anything for that b value. Whatever is there, I need to factor it out. So I'm going to rewrite this and factor out that negative. So my transformations here are reflection across the y and right 2. Since I've gone right 2, 2, 0 is going to be my starting point. So our normal parent function, right 1 up 1, right 4 up 2, right 9 up 3. But what's changed is that we've reflected over the y. Reflecting over the y and anything under the root affects the x's, which means I need to make those x's negative. So I'm going to go left 1 up 1, and left 4 up 2, and left 9 up 3. And that's how you guys can see, again, reflecting over the y for the square root function makes a very different graph. Domain would be -infinity to 2 with a bracket. Range, again, bottom to top, would be 0 to infinity. All right, if you guys feel pretty comfortable, pause the video and try this next one. All right, so here, transformations, I've got a vertical stretch, and I've gone right 3. That means my point of inflection is at 3, 0. From that point, I'm going to follow my parent function pattern, but those points have been stretched by 2. So right 1 up 2, right 8 is going to go a little bit off my graph, up 4, left 1 down 2, and left 8 down 4. And there's my cube root function. And we're done. All right, so the last two are just going to deal with horizontal stretches and compressions. Again, we're going to factor out whatever's in front of that x to make it easier to see my starting point. So I'm going to take that 1/2 and divide it out. If 1/2 comes out, I'm doing 2 divided by 1/2. 2 divided by 1/2 is 2 times 2, which is 4. So transformations I have here, I've got a reflection over the x, a horizontal stretch, left 4, and up 3. So left 4 and up 3 means my starting point has gone left 4 and up 3. Then from there, follow our parent function pattern. Since it's got that 1/2, remember it's opposite. We're stretching horizontally. So I'm going to multiply by 2. Then that negative, it's outside the root. The negative affects the y's. So I'm going to go right 2 and down 1, right 8, and down 2. And then right 18 is going to be off my graph. And then you can see your square root function. Domain farthest left x value is -4. Range, the bottom y value. Be careful here. Make sure you get this in the correct order. It has to be the smallest value first. The lowest y value is -infinity. The highest y value is 3. And those are frequently switched, so be careful on domain and range for those. All right, again, if you feel pretty comfortable, pause the video and try the next one on your own. All right, so first thing I'm going to do is factor out that 2. So this graph has a horizontal compression. And then it's gone right 2 and down 1. So that means my point of inflection is at 2, -1. Pattern from that point of inflection And then what I'm going to do, it's a horizontal compression. Again, we are making that x distance smaller. So I am multiplying those x's by 1/2. So I'm going to go right 1/2, up 1, right 4, up 2, left 1/2, down 1, and left 4, down 2. Domain and range are negative infinity to infinity. All right, so that is it for graphs. Again, pretty simple. Same transformations you've been doing all year. Anything that's under the radical is horizontal. Anything outside the radical is vertical. You need to make sure you know the difference between the two parent functions. And then other than that, really, again, it's the same thing. Anything in front of that x under the radical, make sure you factor it out.